Okay, so we started recording. So let's do this. Okay. All right, so functions is the topic. Functions 2, second part of functions. And as I said, this week we mainly focused on functions questions, things in functions that they don't set very often, not the regular functions questions. And they also did some variations, right? So this class activity had some functions questions and variations questions. Also send some questions to the group for practice. Send some of the solutions since this morning. And what I might do in this session, I might just go through one of them. I think there's one that I need to go through. But can you hear me clearly? And see the screen?
Yes, sir.
Yes, sir.
Good. Right. So so I want to get through this activity and then we'll maybe do one of the questions. I think one of the questions I've not yet done. Sent it to the group. I'll maybe do that one. And then we'll do some questions from past papers. And we work for about 1.5 to 2 hours since we started late today. I don't like the Saturday session to be too long. All right. So first question is this one.
Yes.
Somebody mic is open. Please mute the mic. Nobody's speaking. Please mute the mic. Right. So that's the first question. And it gave us this simple function right here. That simple function. And it asks us for f to the -1. And then here it said hence. We have to solve this equation. So the hence means that we want to use this function. That's what the hence means use this. So that means use that we just asked for. So even though this is a very simple equation that can be solved straightforward, right? They don't want to just solve this straightforward. They want to use the inverse function, this inverse function to solve it. So this is a test of your knowledge of the rule that I introduced in class, which says if f of x, function of x, is equal to some value n, in this case the n is 5, then it implies that the x in this equation, is f to the -1 of the n, provided that f of x is a one-to-one function. So this really only works one-to-one functions because only a one-to-one function can have an inverse. So once the question is set up like that, this is what they want you to do. Right? This is what we are required to do. This is what we're required to know. This is what we're required to use. And that's why I said that this was a must know, must remember item. And we put it in our special questions book. As I don't say questions worded like this very often. Right? Because this is a simple equation to solve, but they don't want you to solve it just like that. So I want to find the f to the -1 the normal way. All right, I will start by saying the f equals, let's use the blue. We'll start by saying that the f is equal to 3x -4. That's a function. And we're going to form the inverse. And when we form the inverse, this which represents range becomes domain on the inverse function x. And this x which represents domain becomes range on the inverse function. Just that range on the inverse function is written with a -1 and it's f to the -1. And then this comes back as -4. So essentially, what we have here is the function. This is the function, the original function presented. And this is the inverse of that function. This is the inverse. It's just that even though this is the inverse, we don't yet have the f to the -1 as a subject. Because I want the function to be represented with the range. The subject must be the range. I want the function to be expressed in terms of x. I want to make that the subject. So therefore, we have to transpose to make this a subject. One can be written in one step. The simple one can be done in one step. So we're transposing everything away from this f. to the minus 1. So I want to move this -4 first. Bring it on this side, it's going to become +4. That's a shortcut we have seen that we are adding 4 to both sides. All right, so I want to get x plus 4. And this is gone. Let's imagine that this is now here. And so now we need to get rid of this 3. To get rid of that 3, what we can do is take it and divide it under this side. It is the same as saying we are dividing both sides by 3. But the shortcut way is to take it and divide it under here. And so the 3 comes under this side. And we're left with just the f to the minus 1. All right, and that really is f to the minus 1 of x. So we can write it. So we can say, therefore, the f to the minus 1 and the of x statement that we left up here, we can also now put it back. You can put it back here now. And that f to the minus 1 of x is now equal to this expression, x plus 4 over 3. It's the same thing, you know, just turn it around and make this on the left side. But if you left it like this, that still will be good. Right? But this now is the inverse function. And the question now wants us to use this inverse function to solve this equation right here. 3x minus 4 equals 5. So I want to set it up like this. I want to say, hence, we are solving the 3x minus 4 equals 5. So the key thing in this equation is to recognize that this right here is really the f of x that we're giving up here. It's really the f of x that we're giving. So we're really solving an equation. We can say i.e. that is, we are really solving f of x equals 5. And if f of x is equal to 5, we can say then, or therefore, that implies that the x that we want out of this equation is f to the minus 1 of 5. We can put inverse on this side. Simple as that. And this is based on the rule that I wrote at the top. A one-to-one function. This one. It's not rocket science, you know. All this is saying, right, is that if the function f maps nx onto n, let me say it again. If the function f maps x onto n, then the inverse function, the inverse function, this inverse function is going to map the n back to the x. That's all that is happening. All right, we're going to see something similar in matrices. I want to also see it again similar in transformation, the use of the inverse. All right, so we really know just solving this. And to solve this, all we have to do is put the 5 in the inverse function here. All right, and so it gets the same answer as you would get to solve it normally. So x becomes equal to, if we put the 5 right here, right here, we're going to get 5 plus 4 on the numerator. 5 plus 4 on the numerator divided by 3. That's what we'll get. We'll put the 5 in there. All right, and then this is really 9 over 3, which works out with 3. So the value of x that makes this equal 5, or this expression equal 5 is 3. That is it. But okay with that? But okay?
Yes, sir.
Moving on to number 2. A simple, straightforward question. This says find the value of x for which this function is undefined. Instead of saying undefined, I could have also said not defined. Same thing. All right, could have said not defined. All right. But what does that mean? It means what value of x cannot be accepted on the domain of that function. What value of x will cause the function not to work? What value of x will cause the function not to be able to produce a real output value? I remember that the x asking for x value, which is a domain value, which x value cannot be in the domain of this function. Remember, for this to be a function, each element in the domain must map to an element in the range. Right? So in other words, what value of x will cause this function not to produce a range value that we know that is defined, not defined. And that happens when the denominator of this fraction becomes equal to 0. That's when a number is undefined. That's when a fraction is undefined, or a rational function. This is called a rational function. It's a form of a ratio, something divided by something else, like a fraction. It is when the denominator becomes equal to 0. So in other words, what value of x will make the denominator 0? Such that, because we cannot divide by 0, the result will be undefined. And that value of x cannot be accepted on this function, cannot be used on the function, it cannot be in the domain of the function. So these are the other ways they could have phrased the same question. They could have said, for example, what value of x cannot be in the domain of this function? What value of x cannot be in the domain? It's this kind of value that will make the denominator 0. So we're going to say h of x is undefined when the expression in the denominator 2x minus 3 becomes equal to 0. So when we solve this now, we're finding that value of x. And we solve that by making the x a subject. Transpose the 3, make it positive, and then divide under the 2. So this color when the x equals 3 over 2 or 1.5. So this value of x cannot be in the domain. This is the answer, no? This is the answer. The function cannot accept that domain value. So this cannot be in the domain. Cannot be in the domain of the function h of x. Because if you put it in the domain, then you won't have a value that it is mapping onto. And it's like you would have a domain with all the values mapping, and then you have that 3 value right here, this value 3 over 2. That is not mapping. You cannot have a value in the domain that is not mapping. But if you put x equals 3 over 2, this denominator becomes 0. And then the value up here divided by 0 over undefined. We'll solve that in the class. So we're going to try it again with the calculator by putting a value divided by 0, and the calculator is going to give us some kind of error message. All right? That's what we have to do. So this is the answer for this question right here. X cannot be 3 over 2. The value of x that will make the function undefined is 3 over 2. So this value cannot be in the domain. In other words, x cannot be equal to 3 over 2 on the function. X cannot be equal to 3 over 2 on the function. That's what I'm saying here. X cannot be equal to 3 over 2. I'll put it down here. Since it will make the function undefined, and the function down here, x cannot be 3 over 2. So 3 over 2 cannot be in the domain. The domain is a set of x values. So x cannot be 3 over 2. But I understand that, but good, I'm just expounding one more time on this so that we can have a clear understanding of it. And also, just in case CSEC change the wording of a question like this, and instead of using the word undefined, they might go and say something about the value of x that to make the function can work, the value of x that cannot be in the domain, something like that. The value of x that is not workable. Anything that means that. Yes, you change the wording of a question, you want to be able to understand still exactly what they're talking about. I just don't know how they phrase. All right. More typically, they'll use the word undefined or not defined, but they don't have to use those words on question. So I want you to understand that 3 over 2 cannot be in the domain. So they might word the question similar to that, something like that. Want to go to that? Everybody okay?
Yes.
All right, let's move on. So number 3 now is a question that is testing our knowledge of how to split a composite function into 2 simple functions. So normally we would go from like g of x and f of x. And we use them and form composite like g of f of x, or we might form f of g of x. That's what we normally do for this field. In this question, which is really set, it is as if we have that function, and in this case, it is f of g. And we have to use this compound function and split composite function, split it out, and get two separate functions from it, g of x and f of x. So this is rarely set. In like 40 years, they set questions requiring us to do this maybe 2 times. We're doing what's coming on our exam, your exam that we're going to do. And so we have to prepare for everything. So once you have ever set it before, we want to cover it, we want to understand, we want to be able to do it, we want to experience it, we want to practice it. And because it is a special question that we don't want to forget, and we want to make sure that we remember to look at it when exam time comes. We put it in our special questions book. Everybody must have a special questions book that we put the special questions in. All right, and this is one of those questions. Because most times the question will ask you to form the composite function. This one is asking us to break a composite function. It's not difficult, but because it's not something that we've done frequently, it might pose a problem to somebody. But people don't like to go in the exam and have to do something brand new for the first time. Right? And so it's good to be exposed to this special question. All right, so let's go. So they give us this composite function, and we have come up with a 2-step method to do it. Right? That will work basically every time. All right, so this composite function is f of g. Okay. And it is equal to 3 into 2x minus 1 plus 2. And this is written this way for particular reason, because you want to be able to identify what the g of x is and what the f of x is. Because this could have been written 6x minus 3 plus 2, which is 6x minus 1. This like that. But it was purposely set out as it is for us to be able to break those two functions. All right, that's why it was set out like this. All right, so we have this composite function, right? And they want to split it. And we came up with a method where we say, okay, we're going to find the inner function first. So this here is the inner function. This has 2 functions. This one is the outer one, call it the outer one. And this one, we call it the inner one. Let's call it that. And to form the composite function, what we would normally do to form it is to substitute the inner one into the outer one like that. So this whole function is what is moved. So if we're going to split this composite function, we really have to do the reverse of how we would form a composite function. We form a composite function by putting g into f. And so now to get the simple function, we have to take this g and pull it back out. But the question is, how do we identify which part of this expression is this inner function that does the moving, that is moving? We identify it as the expression within. Expression within. Remember, when you take the g of x form a composite function, you put it inside the f wherever x is. That's how we do in the reverse. So we use a statement where we say, let the inner function, this is the inner function, be equal to the expression within. And if you look at this over here, it is clear the expression within has to be this. All right, so the first step is to let the inner function, find the inner function first. Make a mic, please. Make a mic. Somebody's mic is open. Be equal to the expression within. Expression within expression within. Firstly, the inner function is the g of x. Another line expression within a different color. Use the screen just to show it. The expression within this expression will have to be this one. It's clearly inside those brackets. That is what we would refer to as expression within. I basically making this g of x equal the expression within as a first step. As a first step in forming this composite function, updating this composite function. Let g of x equal to the expression within, which is 2x minus 1. So then no, it's like you're moving this out and you're moving this out. And like you're bringing in back a x. Like you're bringing in an x here, putting back a x now. And you're also putting in back a x here. Because you're doing the reverse of how you form the composite function. So take out the inner function, take out the expression within, and you replace them with x, form the outer function. So if you do this little construct that I have drawn on the paper, but it's the reverse of what, it's the reverse of how you form a composite function. We're going to say that implies that the f of x, the result after move the inner function and the expression within out, I replace them with x. We're going to end up with f of x equals 3 times x plus 2. This x is where the x where this was a while ago. Replace it with x. But I don't need to put these brackets. I don't need to put them. So I'm just going to take them out. Because that is it. I think almost everybody got this right now. I feel like some person just maybe copy from errors. And it's something that we have to discontinue in the class. I'm going to talk about it when I come back. But they don't benefit from copying, just copying others in the classroom. Don't make any sense at this level. But you can't copy in the exam room. You're preparing for an exam where you have to assume that you're able to copy. If they do it, if it's wrong, bring it to me and let me explain the right thing. If you bring the right thing to me, but you don't understand, you just copy from somebody. You're not helping yourself, you're actually hurting yourself. And persons who allow other students to copy from them, yeah, they're hurting you. As well as they're hurting your friend, they allow your friend to copy from you. And you don't understand why they're copying. It doesn't make any sense at this level. This is not prep school, this is upper school, like high school. Fourth form, fifth form. Don't make any sense. All right. So after we find these two functions now, which is what the first part here we wanted, was to find these two functions from the composite. The next part now wants us to find the inverse of this one, the inverse of that one, the g to the minus one and the f to the minus one. And here's another keyword again, hence. It wants us to find this. To find that, what the hence here means, use these two things, use them, use these two things to find that thing out there. That's what the hence means. Use what I just found, find what I'm asking you for next. Then I said, do this and that. Hence, do something else. The hence means you have to use what was asked for. If the question said hence or otherwise, then you could use what they just asked for as the hence method, or you can do it some other way as the otherwise method. But I guarantee you the otherwise method is always longer and more work. And the hence method is usually dependent on you having knowledge of something, one of those must-know items. And that's why I won't say these are must-know things, because I know that some questions are centered on knowledge of those must-know things. And the question becomes easy and will finish in 1 and 2 lines if you have those must-know things in the head. If you don't have those must-know things, then you have to go think and figure out stuff and do more work for the same mark. It don't make any sense. That's why when I tell you that you must know something, You take the time to know. Study, practice it, write it down multiple times, put it on a flashcard, tell somebody about, explain it to somebody else. You don't have a friend to explain it to your grandmother, your mother, you listen, explain it to your dog. And that way you cement it with yourself. Well, let's do this part now. I want to find f to the minus 1 and g to the minus 1, and hence find fgr to the minus 1. And this must recognize now, guys. This is the inverse of a composite function. I have to know what this is equal to in terms of these two inverses. I can write it on the screen. Here. Inside here is 50 inside here. But that expression here, in terms of these two, is equal to actually the composite of these two. Right? I write it for like this. Down here. This, I'm going to write it down here. This is this. Fg all to the minus 1. I'm just leaving off this Oc5 business for the time. It's equal to the composite of these two. But the important thing that the order that they appear in here is reversed out here. So since the G is second in here, it comes first out here, but it is the inverse of the G that is coming here now, G to the minus 1. And then this comes second, the F, inverse of it, F to the minus 1. We have to remember this thing. We have to remember this physical identity, physical formula, physical rule, this item. We have to remember this in order to answer a question like this. So this, the inverse of this composite function is equal, this is a composite now, is equal to the composite of those two inverse functions. And to the composite of that inverse function, it means that we are putting this f into f to the minus 1 into the g to the minus 1. That's how composite these two. So putting the inverse of f into the inverse of g. That's what we have to do. And some persons leaving off the brackets around here. It's very important because it is the inverse of this whole composite function that we're doing. Right? Let's do it on the screen. All right. So I'm going to find the inverse of each of these first. So I'm going to just call this one G, this one G, and put it as x minus 1. I'm going to inverse it the same way. The G becomes x, and the x here becomes G to minus 1. So now it's 2 G to minus 1 minus this one minus 1. So we're trying to make this G to minus 1 a subject now. So we're going to take this negative 1, bring it on this side and add it, and then take the 2 as a multiplier and divide it on the here. All right. So final result, we'll take this one over here. We're going to get x plus 1, but the sign is reversed, sign is changed from a negative to a positive. And then this 2 is dividing under here. So there's no change of sign because we're dividing. Divided by 2. This now is the g to the minus 1. This is really g to the minus 1 of x. We don't have the of x on it. I'm going to put it on now in red. So that is really what this is. X plus 1 over 2. And we're doing this one now, x to the minus 1. I'm going to invert this one, the inverse of that function. Let's put a line on the middle here. Under the g, the x up there. We're going to start by saying f equals 3x plus 2. I'm going to inverse that. This f is range of the main and inverse function x equals 3 times. This x is the main, it becomes the range on the inverse function, which is written f to the minus 1. And this plus 2 comes back here, plus 2. And again, we have to transpose now, make this the subject. I have to make that the subject now. Make that subject, I'm going to take this 2 over here and subtract and then take this 3 and divide on that. All right, so we're going to get the x over here. The 2 comes over, becomes a minus 2. And then this 3 is divided under over 3. And that now leaves f to the minus 1 as the subject of the minus 1. And that's really f to the minus 1 of x. I can put it here now. That is it. I found the g to the minus 1 and the f to the minus 1. And the question says, hence to this now, hence to this. And I said, to do that, we're going to use this rule. Right? I'm going to say it down here now. Hence, let's see, let's say, hence, the FG all to the minus 1. Again, I'm leaving off this x list. I don't have to put it. Is now equal to g to the minus 1 of f to the minus 1. That's a composite of these two. The g to the minus 1, f to the minus 1. I'm going to put the f to the minus 1 into the g to the minus 1. Like this. Right? And you have to know that this is equal to that. That is the key. It's a must know. So you're finding this, we have to know that it is equal to this right here. You have to know that how you do this now is put the f to the minus 1 into the g to the minus 1. So this is the f to the minus 1 right here. This is the f to the minus 1. And you're putting it into the g to the minus 1 here. Let's see. Space is all of f to the minus 1. All right. And so this now becomes, okay, this x is, I'm going to put all of that, which is the x minus 2 over 3. That's where the x is. Plus this one beside it. And dividing everything by 2. Is it? That's the answer. That is the answer right there. I don't need to put these brackets, but no problem if I put them. That's where the x was. I'm not for the inverse function there. This is not here. And to simplify this, we can basically multiply the numerator and the denominator by 3 by trying to get that 3. So multiply the whole numerator by 3 and multiply the denominator as well by 3. So this 3 will multiply this fraction and that 1. When it multiplies this fraction, this 3 will cancel. All right. And then we multiply this 3, 1 becomes 3. So the end result, if you simplify it, is now x minus 2, and I multiply the 3 by this one. And then the 3 times 1 is 3, plus 3, divided by this 3 times 2 is now 6. And then this 3 and minus 2 is 1. So it really becomes x plus 1 over 6. Why do you go to that?
Yes, sir.
Okay.
Yes, sir.
My time to revise this thing in advance because we're going on to a new topic next class.
Yes, sir. Can you hear me?
Mm-hmm.
So I was wondering, where did you get that 3 over 3 that you times there with?
What? It's 3 over
3 over
3.
yes, sir.
Just that we have simplified an expression like this. Why did I use 3 over 3? You know, 3 over 3 is the same as 1, right? Just that I'm multiplying this by 1. It's just a way to simplify this expression, to get rid of the fraction that is here. To get rid of this 3 that is here, I would have to multiply it by 3. Just that if I multiply the numerator by 3, then I also have to multiply the denominator by 3. So I multiply the numerator by 3, I multiply the denominator also by 3, so that the value of the fraction remains the same. So this was just me adding that multiplication to simplify. As I said, if students left this as the answer, it will still be correct. But just they might ask you to simplify down to that. And in fact, you're normally expected to simplify expressions the lowest term. This is something that we expected to do. But I didn't bother students in the class when I left this because my focus was on them remembering this thing. This was my focus for them to know and use that. Once person got to here, I was okay. But we have to learn how to simplify expressions like this. Don't do that. That answer the question? Hello?
Yes, sir.
Cool. Let's move back in my now. All right, so that was that question. Let's move now down to this last one here, which was a variations question. Let me take this out. Maybe some more. So we're now looking at this question, this variations question. Now, let's just talk about that a little bit one more time. The variation will always be either direct or inverse. All right, we're looking for that. Either direct or inverse. So remember, it's if let's say the two variables are x and y. In this case, it's not x and y, it is the square of x and y. The square of x is really x squared. That's the first thing you want to do, identify the two variables. Don't 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 have to be x and y all the time. And I've sent Christian in the group where we saw f and e, of course, an extension. There's also a question with d and t, distance and time, and s and t, speed and time. There's just all kind of different things that I can say. Mass and pressure, m and p. It can be any two variables. All right, that are related in a way such that they have an inverse variation or a direct variation. So after I get the two variables, the next you're looking for is the word whether it's directly or inversely. In this case, it is directly. But just to remind ourselves, all right? Just remind ourselves, if it's a direct variation, then the first variable is k times the second variable. In this case, the second variable is x squared. That becomes a relationship because it's a direct variation. If it was an inverse variation, and I use the word inversely, it's an inverse variation, then they would say inversely. Then the first variable is k divided by the second variable. So if it was inversely instead of directly, this is what you'd have to write. That's where you start. All right, so that's a starting point with the variations. Writing the equation in the correct form, or writing the relationship in the correct form. So direct is always k times. The first thing is k times the second thing. And inverse is always k over or k divided by the second. The beauty about this one though is that it is always nice to transpose this denominator across here and instead write it as x squared y equals k. Sometimes it's kind of nice to work with this down here instead of that. But if you work with this, the answer is going to be the same. Just going to be the same anyway. And then now, after we decide which of these we're using, the next thing is to find the value of k. That's the method that we're using to do this question. Now, it can be done without finding the value of k. What we are doing in the method, we'll find the value of k first. Now, when we master that method, I don't show you how you can actually do it without calculating the actual value of k. But if you don't, just stick to that method, it is accepted. You find the value of k first. And what will happen is that they will always give you a pair of known values if you use to find the value of k. Right? They'll always give it to you. Sometimes they put it in the table, as is the case here with this one, but sometimes they'll put it in words, right? The values that you can use. It's always a pair of known values. In this table, that pair of known values happen to be these two middle values. And so we're going to be using these to find the k value first. That's the method that we're using to answer this question. All right, find the k value first. All right, so let's set it up now. So again, now, because it is this direct variation, let's go. Because of this direct variation between y and x squared, as is seen in this statement in here, the variation relationship is that, for this question, question 4, relationship is that the first variable y is k times the second variable, which is x squared, square of x. That's a formula. And we want to find this k first. So even if they don't ask for k, the method we're using is one, we'll find k first. So it's going to be find the k value first. And to find the k value, what you do is plug the known values in the table that I have here. plug them in this formula to find the Q. So we're going to use the values x equals 2 and y equals 8 on that formula. All right, so we're going to say, therefore, the y value is 8 right there, 8. So put in 8 there. Equals this Q down, which is trying to find, times the 2, the x value squared in there, 2 squared. Now this 2 squared is actually 4. When I take this 4 and divide it under the 8, I'm going to say that the k is equal to 8 over 4. Now the funny thing is that a lot of persons work with the 8 over 4 in a class. They must always simplify the reverse terms. And 8 over 4 is clearly 2. So why not work with the 2? The 8 over 4 is really 2. 8 divided by 4 is 2. So you know that k is really equal to 2. This is the value of k. What do you do with it? You take it and you put it back in the relationship formula right away. Because a constant is not going to change. So that formula up there, after I put it in there, that formula really now becomes y equals 2x squared. So again, now that I have y equals 2x squared, this now is a formula that they're going to be using to find all the other pieces of information that they want. Which is what information that they want. They want to know the value of P, so they want the value of P and Q. So P is the Y value when the X value is -1. So we can put that pair on this formula. So using this formula on the first pair right here, the X is -1 when the Y is P. Y is P. Then plug these values now in the formula. So you put in P for the Y value right here. So P becomes the subject, equals 2 times. And then this -1 is the X. We're going to put it right here with X is -1 squared. But the -1 squared is a positive 1. So the P equals 2 times of positive 1. 2 times 1 is 2. So the P equals 2. That's on the first pair. So we now know that this value is a 2. And then now, the next one, we're going to work on this pair to find the value of Q. On the second pair, over here, let's do it over here. What we have is that the X is equal to Q when the Y is equal to 18. Again, I'm going to plug these values in this formula. Let's see what we get for the Q. So the Y is 18 right here. So I'm going to write 18. Let's say therefore, 18 is equal to 2 times X squared becomes Q squared. And so that is what we're solving now to find the Q. So to solve the Q, we're going to transpose these away from the Q. We're going to divide by the 2 first and get 18 over 2 equals Q squared. 18 over 2 is 9, so 9 equals Q squared. You're going to take the square root of both sides. To get rid of this square, you take the square root of both sides. So I'm going to square root this 9 and square root this Q squared. This Q squared. So the square root is going to cancel the 2, the power 2. Right? So over here, the power and the square root is gone. So we end up getting the Q equals the square root of 9, because this square root cancels this 2. So we're left with this Q. So Q equals the square root of 9. And the square root of 9 is 3. So we equals the 3. So Q equals 3. That is it. Now look here, when we took the square root here now, normally we really should be considering plus or minus. You know? So it could have been plus or minus 3. But based on this table, it's a direct variation, right? The Q has to be a value greater has to be a value greater than the 2. That's how we couldn't use negative, like direct variation. Now, because remember that the y value is increasing, and so the x value must increase as well. Hold on a sec, guys. I must take this. Hold on, I must decline that. Sorry about that. Sorry about that. Oh, a sec, guys. Sorry about that. Right? So we are ignoring the minus on that for that reason. Because the x value is increasing and the y value must be increasing. So the q cannot go down back to be -3. Cannot. It has to be a value greater than 2. Right? Because it's a direct variation. So as the x increase, as the x increase, the y square will increase. So the values must increase this way. Since these values are increasing this way, or since these values increase in this way, these values must increase as well. Right? So you have to put the 3, the 3. Right, that. That finished that classwork. But okay? Are you good?
Yes, sir.
All right. So
Yes,
I
sir.
sent some. Yes, you have a question?
You understand?
Okay. All right. So I just want to do one question from the work that I sent you on Tuesday. I sent other solutions in the group this morning, well, between last night and this morning. Send them in the group. So I think there was one question that I have not yet done. Let's see which one that was. This one. Let's see. I think it's this one. 2023 question 4. Yes, I didn't do this question. All right, so let me bring up that question. 2023 question 4, and then we might see if we can do a few other questions just to use up the time, right? See if I can find it. It's the last somewhere. CSEC. Okay, this is the best copy of this paper that I will make with all the columns and well, this is it. So you can do it right here. No problem. No problem. This is the last. So I sent this question to the group. The functions question. There's 3 functions in it. As you can see there. Yes, that's something there. This. It's not a bit form. Yes, this is all right, good. So given these 3 functions, f, g, and h, question wants us to what value of what of x is f of a undefined. See it again. It's undefined when the denominator becomes equal to 0. Simple as that. One mark for it to one mark. So it is undefined when it is undefined when the x plus 2 becomes equal to 0. That is, i.e., when the x is equal to negative 2. Okay, this 2 I'm going to go back become negative 2. That is the answer right here. That's an easy. It's undefined in the denominator. The x plus 2 becomes 0. Simple as that. Next part wants us to find g of a quarter. We want to take a quarter and we want to put it in the g function right there. So simply going to become 4 times quarter where the x was. That quarter. 4 times quarter. And then we're going to subtract this 5. 4 times a quarter is 1 minus 5. 1 minus 5 is negative 4. The next part wants h of negative 3. What is h again? H is this one. So right here, right? And click on the screen. So taking this negative 3, I want to substitute it in the h function where the x is up there. That's what we do. And so this is going to become negative 3 all squared plus this one. Negative 3 squared is 9. This is 9 plus part this one. So the answer here is 10. Then down here now, they want f of 0. Remember, for this, we could have also given it to us as f squared of 0. Same thing. Same thing. So instead of writing f of 0, could have given us f squared of 0. Same thing. All right. So before we get, let's see what f was again. Let's go back up here and see what f was again. F was 3 over x plus 2. Let's show x plus 2. F is 3 over x. Want to find f of 0. We have to recognize that this means you do this first. F of 0 first. With f of 0, we're plugging 0 in the f function. All right, so this will become equal to f of, and then the f of 0 no means I'm putting 0 here. I'll put 0 here, I get 3 over 2 left. So it will become f of 3 over 2. But can I understand that? Why is that? But the f of 0 is 3 over 2. The f of 0 part is 3 over 2. F of 0 equals 3 over 2. So put that value there. They want f of 3 over 2 now, means that I want to put 3 over 2 right here with x. But then this now becomes equal to 3 over 3 over 2 with x is plus 2. So this came right here. And then this can be simplified now. To get rid of this fraction, we multiply the denominator by 2. This 2 will cancel fraction on that one. We have to also multiply the numerator by 2. That's it. So this will become 2 times this is 3. Right, so 2 times this on a year is 3. 2 times this 2 is 4. Then 2 times 3 is 6. Let's reduce this to 6 over. Again. Yeah, this question is over now. Oh, wow, another one. What a question, lengthy. I like it. Hey. Another one is to form a composite function. So you see, and then one inverse too. Man, which year was this? 2023? This is a full-on functions question, man. So I want g of h. So let's set it up. Let's write them so we can see which two. We need G and H, right? These two composite things, these two. And write them. So the G is 4x minus 5, and the H is x squared plus 1. Let's copy them down, these two. Those are two functions, right? And this G of H, remember it means H into G, a different color. So the G of H of X, it really means H into the G, this one into this one. And to do that, we're taking all of the H, I'll bring it and put it in the G where the X is. That's how we construct that composite function. We can find that becomes equal to 4 times bracket x squared plus 1 is where the x was, and it's subtracting this 5 here, so it's subtracting that 5. And you can simplify. 4 times x squared is 4x squared. 4 times 1 is 4 minus 5, so negative 1. That's it. But okay with that?
Yes, sir.
All right. The next part now wants g to the minus 1 of negative 2. G to the minus 1 of negative 2. All right. So I think now, no, that let's just run through. I think now is a good time to maybe show you the other way to do it. Let's show it. I'm going to do this by finding g to the minus 1 of x first. That's right. What I want to do to do this. But to do this, we're going to find g to the minus 1 of x first. Then we're going to put the negative 2 in it. G to the minus 1 of the negative 2. All right, so that's what we're going to do. What was the g again? The g is still this guy right here, all right? 4x minus 5. Let's write it down. Let's go for the blue to do it. So the g is actually 4x minus 5. I'm trying to get the inverse first, this. So when I inverse it, and then g is going to become x, and the x is going to become g to minus 1, or g to minus 1 minus 5. We need to transpose everything and make this a subject now. This, make it the subject. I'm going to take this 5 and add it over here first, and get x plus 5. And then take this 4 and divide under, divided by 4. That gives us g to the minus 1. That's g to the minus 1. And we want g to the minus 1 of negative 2. So we're going to put in the of x here now. Really of x. Right? And then so for the purpose for the last part now, we can say from this now, to get this g to the minus 1 of negative 2. All right, g to the minus 1 of negative 2. That's what's coming here. So I'll put negative 2 here as well. So it becomes equal to negative 2 plus 5 divided by 4. So the final answer is 3 over 4. But I write to that.
Sure. Yes, sir.
Thing I'm gonna do maybe 1 or 2 more past papers, just whatever comes up on it. So that was June 2023. Look at January 2023. Let's see what it was. Just randomly I'm picking 2 past papers now. Right. 2023. Let's see what's going on in January. Let's do a couple more. Leave a function first then. Even with this one, I made it. Let's do. Did I give you this one to do? Oh, so familiar. I don't call you this one. Let's check it. I don't think so. I don't think I give it this one.
I don't recall seeing this one, sir.
Uh-huh.
I don't recall seeing this one on the link.
Cool. Let's do it again. Anyway, anyway, to get more equals better. It's not a problem repeating the question. In fact, all these questions that I give you to do on this past paper, you're gonna have to do them again. We'll start to do mock exam. We're gonna do all of them again. So get familiar with them. Every single one, you're gonna do them again at exam time from March. All right, so give us these two functions. This one, three of them. And they want g of x minus 2 this time. So all it means, they want to take the x minus 2 and substitute it in the g function there. So therefore there. And they want us to simplify it. All right, they want us to simplify it. So this g of x minus 2 simply means we're going to substitute x minus 2 in the g function there. X minus 2 all squared. And then subtract this 5. Is it, you know, it's the simplest form. So we can just leave it like that. We're going to have to expand this out and consolidate the constant value with that 5. We expand this out. Well, remember, it is the first term squared, which is x squared. Then twice the product of 2. How do we do twice the product of 2 again? We multiply these two values, the x and the negative 2. We get negative 2x first. We have to double that. So the middle value is negative 4x minus 4x to the middle term. And then the second term squared is a 4. And then this minus 5 is coming back over here. So consolidate, you know, this is only x squared term there. So only x term. And then this becomes negative 1. 4 minus negative 4 plus 5. Negative 1. Positive 4. Sorry. Positive 4 minus 5. 4 minus 5 is negative 1. That is it. But okay with that?
Yes.
All right. The next part now wants f to the minus 1 to the left. I'm going to show you another way to do this now. So normally what we would do, would find f to the minus 1 of x first. And then we'll put in the 11 and get f to the minus 1 of 11. All right? Now work it. But I might just do it 2 ways for you. But let me do the other way for you first. All right? Today. I'm going to show you another way to do this. What I'm going to do, I'm going to say let, all right, first the f of x, remember. So I have it on the screen, is 4x minus 1. 4x minus 1. All right? And you want to find x to the minus 1, 11. Let's put that down. All right? So I'm going to say let, then I'm going to say let this thing that I want equal some number n. Let f to the minus 1 of 11 equal to n. Now, if f to the minus 1 of 11 is equal to n, it means that the 11 is equal to f of n. F of n. And f of n now simply means that we're putting n right there. And so it becomes that 11 is equal to 4n minus 1. When we solve this for n, you have to answer n, because whatever n is, it's what f of 11 is. So we solve this equation now, we have the n. How do we solve this equation? Still have to transpose n. We're going to take this 1, bring it over here, and then divide under the 4. So we're going to get 11 plus 1. Okay, what the negative 1 get 11 plus 1. Divide under the 4 over 4. That is the n. This works out to be 3. And that's 12 over 4 is 3. So right, let me shift this over a bit. Let me shift this over. The solution of it. So this is really n equals 3. So that's it. Therefore, n is equal to 3. Remember what did I say? N equals f to the minus 1 of 11. F to the minus 1 of 11 equals n. So this n is the f to the minus 1 of 11, which was 1. F to the minus 1 of 11. F to the minus 1 of 11. Therefore, equal to 3. Let's do it the normal way, though. Just to show that you will still get the value of 3. All right? Let's do it the normal way. We'll find the inverse first. I'm going to put the word r right here and do it the other way. So we're going to form the inverse first, right? So f equals 4x minus 1. I'm going to inverse that, and the f becomes x equals 4 times this x becomes f to the minus 1 minus 1. There's any method you have to transpose it. You can avoid it. I have to transpose this now. Make that the subject. Transpose and make that the subject. Which means we're going to take this 1 and bring it over here first. We're going to get x plus 1, and then this 4, we're going to take it under and put it here as a 4. That leaves us with f to the minus 1. This is with f to the minus 1 of x. You know, of x now. But you're trying to find f to the minus 1 of 11. So it means that you're going to have to take the 11 and put it in here where the x is. Get that value. You can write that in. And so based on that, so for the building. And so therefore, f to the minus 1 of 11, you're putting 11 here. So putting it here as well. The form is equal to 11 plus 1 over 4, which then is equal to 3 same. So the answer is 3, whatever method you use. So you can watch over the video and try this way. But if you realize whichever method you use, you have to transpose. What you have to transpose, make the subject. Using this method, the value n here had to be transposed to the subject. And it's the same expression that we have here using this method. But then compare this line to this line. So any method you're using, that thing in that position has to be made the subject, but you have to find it in there. Right? So the matter this method I'm using. So when you change method, sometimes a key step is repeat this. Both methods. All right. This can stand down, once each of 1. Right? I'm going to write it here. Same as h squared of 1. So instead of giving you this, it would have given us that in the same thing. All right. What is h of 1? It is h of 1 first coming here. What is h of 1? Let's write down what h is again. The function h of x. What was it again? It was 3 to x, right? 3 to x, yes, 3 to x. That is 3 to the x. So this h of 1 that we're putting in here means 3 to the power 1. But x is 1, right? We're doing 3 to the power 1. 3 to the power 1 is 3, so we're doing h of 3. Then h of 3 now is fine again by putting the 3 into the h function with x's. So this becomes 3 cubed. And 3 cubed means 3 times 3 times 3, which is 27. That is it. That finishes that question. That is it. Are you okay with that?
Yes, fine.
Very good. All right. Somebody check how long we're going now. How long we're going now? How long since start? After around maybe a little after. I'll do one more question. And then if I say that basically repeat of the same thing, they're asking with different numbers. All right. So that's why I have to keep practicing. Keep practicing. Once you keep practicing, you'll find. Because after a while, they realize it's the same thing they keep asking all the time. All right. There's nothing to worry about. All right. So that was January 2023. Let's look at 2024, a recent paper. Let's look at 2024. Let's look at 2024 January. So let's see if there's any function down. Sometimes it comes in section 1, sometimes in section 2. Functions basically. It's just need practice now that really easy stuff. Really, really easy stuff. Practice, 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 practice. I tell people all the time, all mathematical principles can only be fully understood by solving many, 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 many questions. There's some of you who claim not to be understanding the work and hard and all of that. It's simply because you are not practicing. And it's not difficult to know what to practice, because I tell you, just practice the same question that I do. Start to do, practice the same question that I do. That's all you have to do. Start with those first, because at least you see those work already. All right? You see those work already. You see me do questions with those already. So let's practice those questions first, the ones that I do. You could do this question already, You could do it last week. This one. No problem. No more people. We can do it. This one look familiar to anybody? I could do it already. Anybody? I'm saying if this question looks like a question I've done before.
I think you gave us this one. I'm pretty sure you gave us this one.
Should I give it this one? Let's look at let's look at January 2020. Don't I give it this one? Let's look at January 2020. It don't matter now, but if you skip it over now, you're gonna have to do all these questions. But I mean, I'm telling you that you're in my program in this class, you're gonna have to do all these questions over again. So I'm not worried. Every single one of these questions you have to do. You're gonna have to do all the past papers, January and June, all the way back to maybe 2020, 2010. Maybe 2010. Yeah, you have to do all the past papers back to about 2010. You can check how many past papers. You're gonna have to do all of them on the exam condition. So, and I'm not worried if you skip over question now. Right? You'll be doing every single one of them at some point. Let's just do this one and we'll call it a simple, straightforward one. But all the special ones that exist, we are gonna do them, right, at some point. So even these questions we're doing now, we're gonna be repeating them again at some point. Believe me. I do this for question multiple times again. As more math equals better math. All right, so this was this one function. I guess they want us to do everything with it, right? One function. The one's f of 4 plus f of -4. So like we're working out this one, same function, 1 with 4 and 1 with -4, right? So this becomes equal to f of 4 first, meaning putting 4 in there. So it's 2 times 4 plus 7 divided by 5. Plus, that is plus. I want f of -4, so put in a -4 in the same function. So it's 2 times -4 plus 7. Let's write that. 2 times -4 plus 7 divided by 5. What happens is that this becomes an 8 and it becomes a -8. And so they will eliminate each other. Why put each other? So you will left with 7/5 two times. That's what happens. If you want to work out this and work out that, same difference. That the same denominator anyway. What you can do is consolidate everything. This and this, and give me 0. You're going to have 7 plus 7 is 14 over common denominator 5. If I add up the numerator, that's what I'm going to get. It is add them to these. What the common denominator here. What the common denominator. So it can be done that. But I go to that, it's just 14 over 5 grams. Are you okay with that?
Yes, sir.
And sometimes very simple things are just like what to explain. I just do it too simple. This one wants us to find the value of x plus f of x is equal to 9. I'm going to do this question 2 weeks just because. All right. And so hence find x minus 1 of 9. Same thing. X minus 1 of 9. Because whatever value you get for this is such that x is equal to f to the minus 1 of 9. So this is the answer. The same answer that we get up here is the same answer going to be down here. But these two really is the same thing. These two. F of x equals 9. The same as well for x to the minus 1 of 9. So that is what it is. So anyway, let's do it about that. So calculate the value of x for which f of x equals 9. So I'm going to use the f of x and put it equal 9 this time. The same f of x is this 2x plus 7, 2x plus 7 over 5. So we're solving 2x plus 7 over 5. That's 2x plus 7 over 5 equals 9. That's what we're solving. This part of it is there. I'm going to take this 5 and multiply across here first. We will get 2x plus 7 equals 45. We're going to subtract the 7 and divide under the 2. Leave x as a subject. So the x is going to be 45 minus this 7. And then divide that by this 2 on the here. That's what it is. So 45 minus 7 is what? 32. 32 divided by 2, 16. I'm going to check if that is correct. It's like 16. Very good at that.
Yes, sir.
Yes, sir. 35 and 38. 45 minus 38, 38 over 16, 19. Check it again, guys. Check it again. Check it again. Check it again. Check it. That is correct. And then now, this question is asking us, and it's a hence or otherwise, must determine that. All right, must determine that. But I can tell you that is from this, right? You know it already. If you put f of the minus 1 of 9 equals some number, like you're trying to put this equals some number, then it means then that 9 is equal to f of that number. Or just do that up here. Just leave f of something equals 9. Is that something? 19. Right? So the number that we're searching for here is 19. Based on what we just did up here. Because we just did f of x equals 9. And the x was 19. So it means therefore that f of 19 is equal to 9. And so if we transpose the f, that 19 is equal to f to the minus 1, 9. And that's what they're asking us to find. That says 19. So here, that's what we are saying. F to the minus 1 of x9 is n. Based on what we have here, n is this 19. The answer is 19. N really want to look at it. That's like 19. So I think that is good. So, the minus 9. There's only one more for it because you know really need to calculate using the hence method. If using the otherwise method, you're going to have to report x to the minus 1 of x first and then plug in the 9, which is just too much work for one mark. And if you know this little relationship like this, if you know this, f of x equals a number, then x equals f to the minus 1 of that number. Then the other way, if f to the minus 1 of x equals a number, then x equals f of that number. So I can transpose in the function. In the function on this side and to the function on that side, yeah, that's will be the inverse. So the inverse on here comes over here becomes the function. That's it. Either one will work. So this question is testing our knowledge of these simple things. That's what this is testing. Our knowledge of using the hence method. The otherwise method over here will require more work because you have to find f to the minus 1 of x first. And you plug in the 9. But why do that if you can just know these things and apply it? So I most important. Question done. I'm going to stop it there for today, guys. You get more practice on functions going forward. This has finished with functions, you know, on topic. Next time we'll see it is in revision. We're going to see it in revision in December. And then we see it again revised in March. The only good thing about it is that there are some topics to come that will have similar application. Right? Matrices, there are some similar application in matrices, but in particular, transformation about a lot of applications that are similar, and operation and activities that are very similar to what we do in functions. All right. So when we're doing those activities in transformation, this is something we're doing soon. I will remind you and connect it back to these things in function. So that will serve as some kind of revision. We're going to revise function itself in December. We're revising everything that we do up to December, in December. And then we have our big revision, exam preparation, revise review, practice, and so on. Exam preparation in March, where we'll do 1 million of these questions in that time. As functions really is a sure marks topic on the exam paper. Almost every functions question kind of easy to do. Right? It's like a sure marks topic on the exam paper. You know, my mind just tell me that there's one actually the same thing with you. You haven't done. Just trying the mind was trying to tell me. So, we're gonna get back to it at some point, but mind is just telling me. My mind doesn't remind me of one particular one. But one that I think represent to represent some mapping level. I'm not seeing it. I'm not seeing it. So maybe I didn't do that one as well. But we'll eventually get to it. Reason I remember that one because as I was speaking, I was just thinking of the different ways the set functions question and there's that part of the one that just jump out my head. January 2021. All right, let's do that. Let's do that one and never part of it. January 2021. I did send it in the group. On Tuesday, I think it was maybe the last question that I sent to you. January 2021. There are actually two questions on it, you know. A variations question and a function question. Question 2D and 4D. All right, let's get January 2021. And then all the day after that. Sure. All right, January 2021, right here. So let's just do this. And then we can have that video. Again, the function question like set out a little bit different. So Like when I sit out different, but test your true knowledge of what you're doing, and it's not just rote learning, and it's not that you do this, test your real and true understanding. And this thing that's about different. Here we go. Here's a variation question. Here is a variation question right here. And I'm going to stick to the method of finding key first for now, right? Maybe later on, when I know after we go through vision and so on, I'll show you the method. But this is a nice one that could be done without using finding key. All right. If you tell me on the group, if you tell me on the call at the moment to just show you the way to do to actually find the value of key, I'm going to show you this one time because maybe some of you can appreciate it. But let me do the key method first. So it says the distance needed to stop a car D varies directly. So the variables are D and is a direct variation. And it is a square of the speed S, meaning S squared. So this is D. This is directly meaning equal K times, and the variable is the square of the speed, which means S squared. All right, so it's K times, it's K times, not K over K times. That is the thing. So the relationship right away is D equals K S squared. Right off the bat from that statement. It says, speed is traveling at. It says a car traveling at 70. This is the known value they're giving us known. A car traveling at 70, meaning when the S is 70. When S is 70, it requires a distance of 40 meters. The D equals 40 to make a stop. So this information is the find key. That's what they just give us in this line. This information that I'm underlining now is right here. And that is all to find the key value. What can be used to find the key value? If using the find the key value method, and that's a known pair of values. All right, so those values can put in here to find what the key is using the find the key method. All right, so that's a known pair of values. Find the key, we'll write it in. This is what they give us to find the key. Using the find key first method. Then it says now, what distance, this is asking for ID now, is required to stop a car traveling at 8. So this is what they're asking us now, this. So that they're saying, what is D? They're saying, if S equals 80, what is D? What is D? What is D? So they're saying in that question. But I get that? So that's what the question is written in words sometimes. They like to put them in tables. It's very obvious what they wanted to do, but sometimes they'll ask you, put the question in words like this. And so they don't give a lot of space to work. So you have to be very efficient with the use of space. All right, let's follow the process now. But let's do find key. Let's do the do find key first over this side, since we have it here. Right? We're using this to find the key in this expression. How do we do it? Plug these values inside here. Right? So let's find key first over here. Find key first, right? So using these. So the D is 40. I'm going to put 40 equals, so the D is 40. K times, the speed is 70. 70. And squaring it. So divided by the 70 squared, you're going to get 40 over 70 squared is equal to the Q. Right. These are two marks of this question. So I really think they don't want to use the find key first method. So that's why I have to learn that other method. But basically, that is the value of key, and I don't even have to work it out. Right? I don't even have to actually work it out full. I can leave it like this until I reach the end. And then now to do this part now, All right. Knowing this now, I can put this k value here. Right? So I can say therefore the D that I want is really equal to this k, which is 40 over 70 squared times the speed squared. S squared. And then to answer this now is what is the D when the S equals 80? So answering this now is the part in purple. This is our answering now. That means that we're putting the 80 over here. So the D that I want down here will be equal to 40 over 70 squared times putting the 80 for the S, the speed. 80 squared. And that's what we're working out to get the answer. Okay, let's do it with the calculator. I can simplify it down. It's going to calculate values. Calculate a summary inside. There we go. Working this on. I'm going to set it out like this. So I'm going to do a fraction 40 over 70 squared. I'm going to multiply that by 80 squared. And then 52.2. I'm going to put three significant figures like the answer. 52.2 is meters. So I'm going to find that distance. What distance? Distance in this question in meters. I don't know it's meters, but this question gave us 40 meters at the distance for that information. That is it. The variations question we just did. Direct variations question. But okay with that? Very good.
Yes, sir.
All right. Then we need number 4 now. I'm sure the way to do it without finding the key. Sure to do it without finding the key. Pick down fast for me. I just 2 marks, right? I don't want to find it. All right. So we still have to get this right to get this formula, right? All right. So we're not going to find the value of key, the actual value of key. It's almost like the same thing. We're not finding the actual value of key. We still have to set this up. What is now? So based on this formula first, the D equals the different color. The different color. So that we're working the D equals K times S squared. So this statement up here is still going to give us that as our variations formula. What you do without finding the K is you write this and put the D as the K as a subject. So it's like you're going to say the K is equal to D over S squared. You know what that means? It means that D over S squared is a constant. The D over S squared pair for any pair is the same. That's what it means. It's a constant. D over S squared is a constant. So like I can say, okay, let me pair up 2 pairs now, right? Let me show you. So this pair that they want, and this pair that they're giving us. I don't need the blue. All right. So this pair that they gave me and this pair that I want, when I put them in the ratio D over S squared, it must be the same. So see here now, this pair would be D over 80 squared. The distance over the speed squared. But this pair will be equal to the distance over the speed squared for this pair. All times. So that is equal to the distance over here. So it's 40 over the speed squared, 70 squared. So you see, you come back to the same equation in the answer. All I have to do now is take this 80 squared and multiply it across here. So you come back to the same thing in the end. And I did not calculate the value of the key. I did not focus on getting key from it. Because down here, the D now will be equal to 40 over 70 squared, just the same. And then this 80 squared multiplied here. So I will put times 80 squared. I get the same answer, 52.2. So in this method, there was no aim to find the value of k, but the end result is the same, as you can see. The end result is the same. And we did not try to find the value of k. We just set it up like a ratio. The k there, so, and the k there, so it's the same. So realize that based on this expression for the k, the d over the speed squared is always a constant value. So d over the s squared for this pair is equal to the d over the s squared for this pair. I will equate them. All right, so that's what we can do to find the key. Let's go down to number 4. Function in number 4. Let's think this one was set up a little bit different. That's what I said. Let's see. There you go. All right, and there's yet another one that just came to my mind, Another function that must came to my mind. CSEC. I'm going to find it and send it for you today. But it gives us this function, right? And when I write it like that, remember it is the same as f of x equals 3 minus 2x. It's the same thing. So the function over here with f of x is equal to this is the relationship 3 minus 2x, and these are the x values we're plugging in there to get these values. All right, so that's it. And this is a mapping diagram for it. It's a diagram below shows a mapping diagram for the function. Determine the value of a. So a is the value that you have to mark -1 and 2. That's all you know. A is the value of -1. Right? So that's all. Find a. A is f of -1. Say a of f of -1. Put -1 in here. That's what a is. F of -1. All right. A is f of -1. So put -1 in the function. And you get it. So it will be equal to 3 minus 2 times 1. That becomes a positive 2. 2 and 3 is 5. That's 5. All right. This one's a linear function. You could also look at the values. These values are all jumping by 1. Right? But also look at all these values change. If you notice, keep adding 2. Keep minusing 2. Sorry. Right? Keep subtracting 2. Right? So when this way, adding 2 plus 2. Here plus 2. So here I have plus 2 again. And that's why I end up with 5. So forget it that way as well, plus 5. We're using a function method, which is what I just did. Recognize that the a is f of -1. All right, what is the one just to do here? It said determine in simplest form f to the -1. So we're working with the CF function, which is 3 minus 2x. So again, we're going to start by saying the f is actually 3 minus 2x. And we're going to inverse it. And we're going to get x equals 3 minus 2 times f to the -1. Some teachers use x and y. That's okay. You can use that way as well. Want to make this a subject. What I'm going to do, I'm going to take all of this and bring it over this side, make it positive first, and take this x over this side. I'm going to get 2f to the -1 equals 3 minus x. And then to make this a subject, I'm going to take this one, divide it under. I'm going to get f to the -1 equals 3 minus x over 2. This is really f to the -1 of x. So then put that back in there. F to the -1 of x. And that is it. Then here now, they want f squared. And the important thing with this one is to remember that f squared of x means f of x. Don't square anything, guys. Don't go multiplying and squaring anything. You're putting the f function back into itself. So if I were to write down the f function twice, just to show how it is, like I have f equals, what is it again? 3 minus 2x. 3 minus 2x. And I have f again equals 3 minus 2x. And this means I'm substituting one into the next, right? So like I'm taking f, this f, and I'm substituting it back into f where the x is right here. And I'm doing that construct with this. So this will become equal to 3 minus, that's a 3 minus 2 times the entire function coming here again. 2 times the entire function coming back here. 3 minus 2x. That is it. And we're going to simplify it. 3, I'm going to say minus 2 times each of these things in the bracket. I'm careful because of the minus. So it's minus 2 times 3 is negative 6. Then minus 2 times minus 2 becomes a positive 4x. So the final answer is this is negative 3 plus 4x. Same as 4x minus 3. That's square. I like this question. I like the fact that we did this one. I see another part here. This now, this is just take the value of. Remember I told in class that you expected to know this. This don't need no calculation, but it's 1 mark per yes, 1 mark. But the answer for this has to be negative 2. That's the answer. Why is it negative 2? But the function and the inverse, they reverse what each other did. So some person will have to work out this part first, and then work out the fundamental. If they don't know, and then I told you this in the class, something that you must know. And I put it on the little classwork that we did as well, the WhatsApp work, that f to the minus 1 of f of any number is still equal to that number. And if you reverse these, f of f to the minus 1 of any number is equal to that same number. And so we can put in, instead of the number, we can put in x there. So instead we could say f to the minus 1 of f of x must equal x. And f of f to the minus 1 of x must equal x. Because it's like the f to the minus 1 do something, you know. And the f just reverses it. What does that mean? And even if they had f to the minus 1, f to the minus 1 of f of minus 2, the answer is minus 2. But this one is equal to minus 2. Right? So if you reckon this, then it's going to be that the f of f to the minus 1 of minus 2 is simply equal to negative 2. But the function is inverse reverses what each one does. So the function reverses what the inverse does, and the inverse reverses what the function does. And in this expression means this expression right here. Right? It means this first followed by that. So the function does something with the negative 2. And you bring in the inverse. The inverse is going to reverse it back to the negative 2. It's like this. It's like you have negative 2. Right? Like you have negative 2 here. And you put the function on it. In this case, the inverse on it. You put the inverse on it. So the inverse f to the minus 1, we're going to take it to some value n that we don't even need to know. Right? That's what the function is going to do. So this part of it would work out to be n. And then no, not that one. This part of it, sorry. This part of it would work out to be n. And you're taking the f and putting that on the n now. We're going to take the f, and the f is going to reverse it. So the f is going to do reverse it. So that's why you start at 2 and end back up negative 2 and end back up negative 2. The entire function and reverse one after the next. So the answer for this one is just 2. I think we're done with this question. Yes. But okay, one name there now, for sure. But good at that?
Yes, sir.
Yes, sir.
All right, guys. So remember, no class tomorrow and no class Monday. I'm going to send some work to the group. What I'm going to do, and Wednesday and Thursday, I'm gonna do 1-day topics. There are some topics that you can just do and learn and understand and so on in 1 day. I usually do those topics like in March, but I'm gonna do one of them tomorrow. One of them Wednesday and Thursday because I can't have class tomorrow and Monday. That's the only reason. And it's not because of the holiday where I'm not having class on Monday, because I'm attending a funeral tomorrow. But anything I do on the Sunday, I do the same thing on the Monday. But since I'm not having class tomorrow, Sunday, I decided not to have class Monday either. I don't want the two groups to be in sync. Have to work in the same thing in two groups, because everybody's in the same group. All right, so I'm going to do a 1-day topic, Wednesday and Thursday, and so we'll start the next topic that I intended to do next week. That topic is quarter judge. We're going to start that topic next week, Sunday. We're doing a 1 topic, Wednesday and Thursday, same topic. Wednesday for the Sunday, Wednesday group, Thursday for the Monday, Thursday group. That is the plan. Nobody must come to class. Guys, that is it. So see you all in class Wednesday and Thursday. I think I'm going to send some up to the group, if not tomorrow, Monday for sure. All right, bye everybody.
Good, sir.
Okay, bye-bye.
Bye, sir.
Remember, redo all the examples that I did. Redo all the questions. I want to send the video to the group. Redo all the questions that I did. Watch the video and redo all the questions, please. Bye now.